look at a simple average and just get that feeling that it's not telling you the whole story? Well, today we're going to unlock a really powerful, but surprisingly simple data analysis skill, and we're going to do it by tackling a question that's on a lot of people's minds. How much does your college major really impact your starting salary? Get ready because you're about to see data in a whole new way. Okay, so here's the game plan. We'll kick things off with that million-dollar question. Then we're going to look beyond just the average number to find the real story hiding in the data. After that, we'll put some names to the concepts we find. I'll walk you through a simple three-step process anyone can use, and then we'll wrap up by showing you how this is basically your new analytical superpower. All right, let's get into it. First up, the million-dollar question. And for a lot of students trying to figure things out, that's exactly what this feels like. And here it is, the question that starts 1,000 family dinner debates, right? Does your major lock you into a certain financial path? I mean, on the surface, the answer seems kind of obvious, but is it really? Let's take a look at the data. So at first glance, this table seems to spell it all out pretty clearly. You've got data science majors starting out at an average of $95,000. Then you have history at $55,000 and fine arts down at $45,000. It really feels like case closed, doesn't it? Data science is the clear winner. And yeah, when you throw it on a bar chart like this, that conclusion feels even more solid. I mean, look at that massive bar for data science. It makes it really easy to just stop there and say, okay, we have our answer. But here's the thing, that average, that one single number, that's just the headline. The real story is always in the details. So let's go beyond the average. This is where we really start to dig in and uncover that hidden story the data is trying to tell us. Now watch what happens when we add just one more piece of information to our table. Standard deviation. Don't worry about the fancy name. All this number measures is the spread, how consistent the salaries are. So for data science, it's super low, only $5,000. That means most grads are earning salaries really close to that $95K average. But then you look at fine arts, wow. A massive $25,000 standard deviation, and that tells a completely different story. And this lays it all out perfectly. What we're actually looking at are two totally different kinds of career paths. Data science, without low spread, is predictable, it's stable, it's a reliable path. Fine arts, on the other hand, with that huge spread, well, that's a high-risk, high-reward game. Sure, the average is lower, but that huge spread means some grads could be making way more than the average, while a lot of others are making much less. It's a path of huge variability. So believe it or not, you've just used a fundamental concept in data analysis, completely intuitively. Now, let's just put the official names on these ideas so you can add them to your own toolkit. First up, we've got the mean. This is just the technical term for the average value, the number we all know and love. It gives us that center point of the data. In our example, it was the average starting salary. It's the headline. And here's our new best friend, the standard deviation. This is all about the spread. Think of it this way. A low standard deviation is like a super reliable train that always shows up within a minute or two of when it's supposed to. A high standard deviation, that's more like an unpredictable bus. It might be 20 minutes early, it might be 20 minutes late, you just don't know. It tells you all about consistency and risk. All right, next up is the quantitative variable. Now that sounds way more complicated than it is. It's just the thing you're actually measuring, the number itself. For us, that was the starting salary in dollars, simple as that. And to go with that, we have the categorical variable. These are just the different buckets or groups you're comparing. In our analysis, we had 3 categories, right? Data science, history, and fine arts. So the university major was our categorical variable. Now, here's the best part. Getting these kinds of powerful insights isn't some kind of statistical magic. It's actually a really simple, repeatable framework. Let's just walk through the 3 steps real quick. So, step 1, define your quantitative metric. What's the number you're measuring? We did that. It was starting salary. Step 2, define your categorical groups. Which groups are you comparing? We did that too, the university majors. And step 3, just calculate the stats for each group. And that's exactly what we did when we found the mean and the standard deviation for each major. See? You've already did it. It's that straightforward. And now for my favorite part. This whole thing. It isn't just about salaries and college majors. You've just learned a technique you can apply almost anywhere to get much deeper, much more meaningful answers from data. This is your new analytical superpower. I mean, just think about it. If you're running a business, you could ask, which support channel, phone, email, or live chat, gives us the highest average customer satisfaction score? And which one is the most consistent? As a student, you could ask, which of these study methods gets better test scores on average? And which one is the most reliable? You see, you're no longer just asking, what's the average? You're now asking, what's the average and what does the spread look like? So from now on, the next time you see some headline that just gives you a simple average, I want you to pause for a second and ask yourself, okay, but what about the spread? What's the story of the standard deviation? Because now you know that looking at both the center and the spread is how you find what's really going on. The only question left is, what hidden stories are waiting out there for you to find in the data all around you?